Welcome to this section on an introduction to TensorFlow 2. Before talking about TensorFlow, let's look at the code we had previously written for an artificial neural network. Using this code, we saw how setting up a model, compiling it, and then training it was very easy once we had built the different layers which make up this model. That's the sigmoid, softmax, the linear, and every other layer which we are to use in our model. And then for the training, we have the different optimizers. And finally, we have this model class which permits us actually train our model and then compile our different models. This required us to master the forward propagation and then the back propagation algorithm. Now, what if you are a deep learning practitioner for a big company and you don't necessarily want to always rewrite the code for linear, sigmoid, softmax, compiler, or the fit each time you want to train a model, or each time you have some data on which you want to fit a particular model? You will find that it's going to be very practical to use a deep learning library or a machine learning library which permits you do just what we just did here. That is, just stack up layers and then compile and then finally train your model, later on evaluate, and also do some plots very easily. One of the most prominent of these machine learning libraries is TensorFlow by Google. Let's take a quick look at TensorFlow code as compared to the code we previously wrote. While taking note that with our code, we had to rewrite all these different layers, and then the model class was rewritten with the different loss functions and optimizers. Whereas with TensorFlow code, all you need to do is to import some modules which come with TensorFlow, import TensorFlow, and then the syntax is quite similar to what we just did right up here. We have a model.add dense layer. Yeah, dense layer is the same as a linear layer. Activation, we have the sigmoid, we have compile, although yeah, we just had the difference with this. And then we have this loss function which we have already without actually having to rewrite it. So we have common loss functions like the binary cross entropy, categorical cross entropy, and mean square error are given already. We have this optimizer which is given the SGD. We have it automatically without having to rewrite this code. So we'll find that working with this machine learning libraries is quite interesting, because once you have a problem, the code is quite easy to write as compared to when we're working from scratch. So welcome to TensorFlow's official website. It's an end-to-end open source machine learning platform. TensorFlow is also open source. It has a comprehensive, flexible ecosystem of tools, libraries, and community resources that lets researchers push the state-of-the-art in machine learning, and developers easily build and develop or deploy machine learning powered applications. Now, whether you're training your machine learning model on your GPU or on Colab, or you're training your machine learning model in a browser, or you're training your machine learning model to be deployed on mobile and embedded devices, or also if you are deploying in large-scale production environments, TensorFlow is the right place. We also have easy model building, robust machine learning production anywhere, and powerful experimentation for research. So here are some of solutions to common machine learning problems which are made available on the TensorFlow site. So here are some startups which use TensorFlow to solve their machine learning problems. Here we have developers who help doctors detect respiratory diseases using machine learning. Here we have an enterprise, that is Airbnb, which categorizes photos using TensorFlow, and for researchers in the medical domain, they are learning how to prescribe the right antibiotics using TensorFlow. You could connect with TensorFlow service partners, a list of companies, well-known companies which use TensorFlow, Airbnb, Coca-Cola, DeepMind, General Electric, Healthcare, Google, Intel, NERSC, and Twitter. So you could click here to see many more companies using TensorFlow. News and announcement, we have discussed by deeplearning.ai. You could share work on Twitter, that's TensorFlow's official Twitter channel. You could integrate responsible AI practices into your machine learning workflow. You could differentiate yourself by getting the TensorFlow developer certificate. And at the end of this course, you could go straight away to look at the syllabus and then get prepared and obtain this certificate. And finally, we have some resources and community support. In order for TensorFlow permit researchers, developers, and other practitioners make use of machine learning to solve set problems, TensorFlow has different models for different tasks. It also has different models which permit us work with different kinds of data sets. And then we have models which permit us do modeling very easily. So we have different kind of prefabricated models already. So we just have to call on these models and then they just do the work for us. And then we also have many losses which come with TensorFlow. Then TensorFlow 2 has models which permit us do training and optimization very easily, performance measurement very easily, validation and testing very easily, and then finally take corrective measures so that our model can best represent the data set we're working with. We shall take a quick overview of TensorFlow's models. We have tf.audio, which is used to treat audio data sets, tf.autodiff, which is used for auto differentiation, tf.autograph for a similar purpose, but this time around in building our models in the form of graphs, tf.bitwise, tf.compat. It's important to note that before we got to this TensorFlow version of 2.4.0, we've gone through many other versions, so hence the need for this tf.compatibility or compat module. tf.config, tf.data, debugging, distribute, which is used when training models on different devices. Then we have tf.dtypes, the different kind of data types we work with can be controlled and monitored using this tf.dtypes. We have tf.eras, tf.estimator, then tf.image, which is something we're going to use very much, especially when it comes to data augmentation. As you could see right here, we're going to look at data augmentation shortly. Then we could look at other models, tf.io, that's tf.input output. We have this. And then tf.keras is kind of like the most popular of these models, as the keras API was integrated with TensorFlow from version 2, that's from TensorFlow 2.00. So with this integration, you have this tf.keras model in TensorFlow. And if you take a quick overview of this model, you have activations, that's activation functions, different applications, the back end, callbacks, as we know, data sets, constraints, estimators, initializers. Now this experimental is kind of made of models which are still being developed. Then we have the initializers we've seen, we have the different layers. We had the dense layer we had seen just previously, which is actually the linear layer. So this is what we've been used to for now, but we are going to see how these other layers come to play later on. Then we have losses. We have had to discuss about losses previously. So the binary cross entropy loss, categorical cross entropy loss, and many other losses which we shall work with in the future. And then we have metrics to measure how well our model behaves. Accuracy, AUC, that's area under the curve. Binary accuracy, binary cross entropy, categorical accuracy, categorical cross entropy, categorical hinge, cosine similarity, and many others. Now it should be noted here that the accuracy is kind of like differentiated. That's when our problem is one in which we have many outputs or many different types of outputs, we could use categorical accuracy. But when we just have just two possibilities in the outputs, we use this binary accuracy. And there are many other metrics we could use here to measure how well our model is performing, as you could see. So never mind if you could see this very long list and you're wondering if you will be able to like go through this sometime. Now, what's important to know here is you just have to work on problems. So the more problems you work, the more you may encounter these different metrics. And this list isn't even complete, as for a particular problem, you may even define a metric which is better at quantifying or seeing whether your model behaves or performs well as compared to those metrics available here. So sometimes you may have to write your own metrics, and TensorFlow as well gives you the room to do that very easily. And this goes same with the losses. So if you have a loss that you don't actually find here, you could have a custom, you could write out a custom loss which will permit you actually train your model very well. We have mixed precision, which helps reduce the size of our models. We have models, so this kind of helps us, as you could see, clone a model, load a model, model from configuration, load a model from a JSON file, load a model from a YML file, and then save models. Then we have optimizers. We've seen this already. We have ADA Delta, ADA Grad, ADAM, which we had discussed already, ADA Max, and many other optimizers. While taking note that under these optimizers, we have this learning rate schedulers. Recall we had seen learning rate scheduling before. So in this case, we don't need to actually write the code for this. All we need is maybe to make use of this exponential decay in learning rate, inverse time decay in learning rate, and so on and so forth. And not forgetting that TensorFlow always gives room for you to write your own custom models, so or custom sub models. And then we go to another very interesting model, which is that of pre-processing. We know that all these models are part of the TF.Keras model. So we have this pre-processing, which when we start working, we shall see how interesting it is, because it kind of simplifies our task, as there are many things we could use, say OpenCV or some other computer vision library when it comes to this kind of data. But with TensorFlow, pre-processing is made quite easy as compared to without TensorFlow. We also have sequence data, time series data, and textual data. So we have here the one hot, which is very popular. So instead of just working, or instead of just recording or rewriting the one hot on your own, you just have to call it from here. We also have regularizers, and then utils. So this is kind of like general utilities which we could use when training a model. So if we take, for example, this plot model, so you see here you could plot a model. If you take, for example, to categorical, you could convert your data and put in the form in which you may want it to be in. We also have these wrappers, and then this scikit-learn. So we'll see how we could link up scikit-learn and Keras. So we could close up this TF.Keras model. We have TF.Linearc. This actually stands for linear algebra. So if you want to carry out some linear algebra operations, you could just simply get them from here. So we have much of this which has already been written for us. There we go. We have TF.Lite. So this actually comes to play when working with embedded devices and mobile devices, as many of the models we shall be building wouldn't be efficient or wouldn't even work in embedded or mobile devices because of the size and also the time they would take to run a model. So in this tf.light, we kind of like modify the model so that it could get into this embedded devices or mobile devices. Then we have tf.lookup, tf.math, and many other models which you could explore and which we are going to see in the future. And then for TensorFlow classes or classes which come with the TF model, we have this aggregate method, critical section, type, and this other classes. We have different functions which we shall see later on how they could intervene. Now it's important to note that many times we shall be working with TensorFlow tensors, or we could just say TensorFlow arrays instead of NumPy arrays. So let's take the example of say argmin. So we could take this argmin. So instead of working with say numpy.argmin, we're going to be using tf.argmin. So it's important that you get used to as many of these functions as possible, so that depending on the problem, you just have to pick any one of them which could easily solve your problem and then make use of it in your specified task. So with this, we complete this section and see you on the next section.